Hi, Abhishek.
Sir, it's better that we start, right?
Okay.
People will keep joining. Yeah, that will always.
All right. Sure. So, thanks, guys, for joining me. Let me just quickly start sharing my screen and then we'll begin. I hope my screen is visible.
Yeah, it's visible.
All right. Okay. So, I welcome you all. In this session, we'll be discussing about AKS. So, it is a continuation to one of the other workshops that I did earlier, which was Introduction to AKS. And in this workshop session, we'll be majorly looking into how Azure AKS is incorporating security, how we can have different RBAC rules in Kubernetes, and how we can integrate Azure Active Directory with Azure Kubernetes Service. So that will be the main interaction of this workshop here. So without further ado, let's hop on right into our presentations. So before beginning and jumping onto AKS, we'll have a quick walkthrough about Azure Active Directory and how Azure Active Directory is handling the identity management, what exactly identity is. So when we talk about Azure Active Directory is nothing but a multi-tenant cloud-based identity management system. So Microsoft has been into identity management for quite a long time because Windows Server Active Directory has been in existence since inception. Now they have extended it to their cloud solutions as well. So Azure has its own hosted Active Directory solution where we can manage our entire identity and all our user base in the organization. So that is Azure Active Directory. Let me just quickly show you guys as well. In Azure where we can find Active Directory. So whenever you create any tenant, whenever you create a new account in Azure, you will be getting a default directory for your entire subscription. That will be your default Active Directory. The portal is pretty slow these days. All right. So in all the services, we can see Azure Active Directory. This is the Azure Active Directory. And this is the place where we can see all the identities, all the users and groups that we create in Azure. So if I go to users, you can see there are multiple users created in my subscription. All these users are in a sense an identity. Now the second thing that comes to our mind is what exactly is an identity when we talk about identity management. So identity is anything and everything that can be authenticated. So it can be a user, it can be a group, it can be an application, it can be a virtual machine. So anything and everything which we can authenticate is considered to be an identity. And that is the entire principle which Azure Directory also follows. So we have different identities using which we authenticate for various purposes that we do. Now, how the Azure Active Directory identity provider or identity management is helping us. So when we talk about identity management using Azure Active Directory, we have multiple benefits that we can get. All right, we have all the identities stored in Azure Active Directory only, because if we take the example or if we jump back to a few years back when Active Directory was not that much into picture. So then how things used to happen is people used to have a database. So people used to have a database. There were different users. There were multiple users which were utilizing a particular application or a particular service. Now all those users were using or authenticating with the application, whatsoever service we are having. using the username and password. The primary mode of authentication those days used to be usernames and passwords. Now, all these usernames and passwords were stored in a centralized database, and the application would connect with this database in order to authenticate all the users which are coming in. So, this application is in turn connected with this particular database, and this database will return the authenticated identity to our application. So, the application checks for the authenticating identity. All right. And the database returns the validation for the authenticating identity. So this is what the flow used to be. So if any actor or any user in our scenario is trying to authenticate with this application, this user will be providing its username and password. All right. Using his username or password, the user will be interacting with the application, and the application in turn will be going into the database, validating these credentials. And if those credentials are validated, the user is granted the access. All right. So if it is granted by the application, the database provided the confirmation, then the user will be having access to the application. So this was the general flow which used to happen. All right, a user will come, authenticate with the application, get the credentials validated, and based on the validation, if the credentials are valid, user will be allowed in the application. If not, the user will not be able to use the application. All right. Now, the primary challenge which came across using this approach going forward was that it's pretty hard to manage a giant user base in terms of credentials, because you will be incurring the database cost. You will be having multiple entries, people will be changing their passwords, there will be new users coming, users going out. So managing a centralized database was pretty hectic and really costly. Now, Active Directory has mitigated this issue which we were having with the standard databases. All the user identities, all the identities which we will be authenticating are now stored in our Active Directory only. We do not have to maintain any specific database. We don't have to manage the database by ourselves. Azure takes care of all these things. And since Azure and Microsoft is pretty old in managing identities. They have been providing the identity management solution in terms of Active Directories. So they are pretty well versed how things flow and how they can ensure better security of all these identities. So we get better security, we get better management using Azure Active Directory. So this is a brief about Azure Active Directory. Now let's look into how Azure Active Directory flows, how the authentication mechanism actually flows in Active Directory. I believe the standard authentication mechanism is pretty much clear to everybody. I won't be able to go into the chat again. So if there are any questions, please drop the queries in the chat box. So moving ahead now, this is the actual flow of Azure Active Directory, how the actual authentication happens in Active Directory. So what happens is, I have a client. The client will still be utilizing the username and password. He will be having some sort of credentials. That particular user will be having some sort of credentials. But the difference that occurs now is, the user will not directly communicate with the server or my application now. The user or my client will go through Active Directory first. The client will specify his credentials to Azure Active Directory. Then Azure Active Directory returns a particular token. A token based authentication is enabled. So the token based authentication is better than using plain passwords because tokens are revised with every authentication. So you are pretty secure in terms of your credential. Even if somebody else gets your credential, the credentials, that particular token will expire after defined set of time. So we are pretty safe that we are not exposing all our credentials directly. So AD returns authentication token to the client. This token is then passed by the client to the server. Then once the server receives this token is passed on to the Azure Active Directory. Server communicates with Azure Active Directory based on the trust relationship that it is having. And it gets some authentication details from Azure Active Directory. Once those details are returned from the Active Directory to our server, the server validates the token that client has provided. If the token provided by the client matches the token that Azure Active Directory has returned, the server will be providing the access to our particular client. As a result, the client will be authenticated to that particular server or the application. So this is how exactly Azure Active Directory is playing its role in securing the authentication mechanism for different clients and servers. So this is the standard flow. All right. So moving on ahead. So it's the same diagram that I just explained that I created. So now we'll be talking about access in AKS. So I have also created one cluster. Okay, it's not yet created. All right, till the cluster is getting created, we'll discuss the access in AKS or Kubernetes as such. So whenever we create a new AKS cluster, or whenever we are creating a Kubernetes cluster in Azure, we have to connect to that Kubernetes cluster first. So to connect to the AKS cluster, in general, we are having two options which we can utilize. So let me just all right. Now we'll take this as our AKS cluster for instance, or let's create the AKS cluster inside it. It will be our resource group only. Then this is my AKS cluster. So now to access this AKS cluster, I primarily have two generalized options using which I can directly access my AKS clusters. So the first being to utilize the Azure Cloud Shell. So first is to use Azure Cloud Shell. Now how Cloud Shell helps us is Cloud Shell is already having kubectl installed. So I don't have to install any specific binary when I'm using Cloud Shell. I can directly interact with my cluster. So I can directly interact with my cluster using and the command that we use in order to connect to our cluster is AKS get credentials. And then we specify the resource group name where my cluster is present and then the name of my AKS cluster. So using these commands I can directly interact with my AKS cluster when I am authenticating or connecting using Azure Cloud Shell. Now the second approach is, most of the time we will not be directly interacting with our AKS cluster using the Cloud Shell. We will be interacting with the AKS cluster using our own machine. So there we need to, or user machine. So in the user machine, we need two major components. One is Azure CLI and the other is kubectl. That is the command line utility with which we perform various Kubernetes operations. So once these two are installed in our user machine, then we can simply do a easy login first. Because in the Cloud Shell, we are already logged in. So we don't have to explicitly log into our subscription or our account again. All right. So there we can directly run the AKS command and connect with our cluster and start doing our stuff. But when we are with an our user machine, there we need to log into our account first. So first we have to do our easy login there. Easy login, and then we can go with our easy AKS cluster. All right. So these are the two standard ways in which we interact with our AKS cluster. Let me just quickly check if it is. Okay, it's in progress. All right. These are the two standard ways in which we can interact with our AKS cluster. Now, there is one catch while we are interacting with our AKS cluster in this fashion. So whenever we are interacting or we are getting this credentials from AKS cluster, what actually happens is my AKS cluster provides a kubeconfig file. There is a kubeconfig file which is provided, and what this file contains all the information about my cluster. So this kubeconfig file contains all the information about my cluster, and if I specify or I share this kubeconfig file with some other user, that user can also authenticate with my or use my AKS cluster right away. So this is one catch which we get in the standard access mechanism to AKS cluster. Now, this can be a security vulnerability or a security overhead when we are working in an enterprise. So there we do not want everybody to have access to all the components inside a cluster. All right, we would require some users to have limited access. All right, the users that will not be utilizing our AKS cluster, or who will not be managing our AKS cluster, or just be consuming the cluster as standard users. So for those users, we will not be requiring, or we do not want them to have the access to alter anything. But the standard mechanism is allowing all those things. So this is what we control using RBACs and the AD integration that we'll be doing. So AKS or Kubernetes in itself does not have any identity management solution per se. So there are no identity managing management integrations that we get in Kubernetes out of the box. The way we control accesses in Kubernetes cluster is based on majorly two items: roles and role bindings. All right. So we have roles and we have cluster roles. There are two type of roles that we have in Kubernetes. So in Kubernetes we have Kubernetes or AKS in our scenario here. We have RBAC, and that RBAC primarily comprises of two components. So There are two primary RBAC control items which Kubernetes utilizes. One is a role and the other one is a cluster role. So now there are certain differences when we talk about roles and cluster roles. So when we talk about creating a role or utilizing a role, so role is namespace specific. Namespace specific. That means it only provides access or privileges over to a certain namespace. So if we want to restrict the access or we want to restrict the utilization to a specified namespace only, then we take into account our roles. And when we talk about cluster roles are cluster wide. So they do not span to a specific namespace, they span to the entire cluster. So if I have created a cluster role and I've defined the permissions in a cluster role, those permissions will be applicable throughout the cluster. So there are certain permissions that we can provide when we are talking about roles. So the commonly utilized permissions that we have include get, watch, list, describe, and delete. These are the commonly used permissions that we have in Kubernetes RBAC. So all these permissions or all these verbs are applicable to both roles and cluster roles. So if I have specified just the permission to get something as a cluster role, so that particular identity will only be able to get the resources. If I want to list or if I want to describe anything, if I want to delete anything, I won't be able to because I don't have those permissions. Same goes with the role. If we attach any of this permission to a specific role, only those permissions will be applicable. Apart from that, any other permission will not be specified. It's taking more time. All right, till then let me just quickly show you how a role looks like or a cluster role looks like. So this is how a cluster role looks like. So we have the API version, the Kubernetes API version under which cluster role folds. The kind, that is cluster role. Metadata contains the name of our cluster role. And now this is the main part, rules, the API group, the main API group. And now you can see we can specify resources and verbs. Resources are the Kubernetes objects on which we want the access to be present. And verbs are the actual permission which we are providing to any particular identity. So in resources, we have specified nodes. So this particular cluster role provides get, watch, and list permissions over the nodes. So on the nodes, I can perform these three operations using this cluster role. If I try to do anything else, I won't be able to do it because they are not the part of my permission list. All right. So this is how a cluster role looks like. A role looks the same. The only difference is we change the kind from cluster role to role. It also follows the same paradigm. One addition that we'll be having in a role is the namespace also. So here we are specifying our API groups. There will be specifying a namespace also. So on a particular namespace, which all components we want and what permissions do we want. All right. So this is what our role and a cluster role is. So once our role or cluster role is created, then we bind the particular cluster role or a role with the defined role binding or cluster role binding. So what role binding or cluster role binding does is cluster role binding binds a particular role to a defined service account. Service account is also an object in Kubernetes which we use for programmatic accesses. All right, we create a service account and we provide the permissions to that particular service account, which is then used to perform various operations in our cluster. Or we can attach a particular role or a cluster role to a user also. So cluster role binding or role binding helps attach the particular permissions that we have specified in our roles to the target identity, and that identity can be a user or a service account. So in our AD integration demo, we'll be utilizing users. So that's why we'll be attaching a cluster role with a specific user so that we can see how this makes a difference. All right. Okay, my cluster is taking more time than it should. So this is how RBAC is handled in AKS. Cluster creation is taking time, as I can, we can have a working session as well where I can show you how the roles and cluster roles are defined, the default roles and cluster roles that we have. There are certain default rules and cluster rules already created in our AKS cluster. Using those cluster rules and role bindings, our objects, the pods, the deployments, those deployments interact with or authenticate with the main API server. So they are already created at the time of creation when we create our AKS cluster. So those roles and cluster roles we do not explicitly create. Those are the default cluster roles and roles, and they are used by all the deployments in order to authenticate with the API server.
So I wanted to ask you one thing, like all these processes that we are seeing, right? Like if we take it on a local system, if we take
Uh-huh.
AKS CLI, and when we start
Uh-huh.
working towards that, or the same monitor and the policy still remains the same according to what we have in the portal, or else how is it going to change when we take the Kubernetes cluster through the local system, like we do AKS for our through our local system also, right? How is the
Yes.
policies and the monitoring different there, and how is the policing and the monitoring different when we are working directly from the portal?
So the major difference and the only difference that we get when we are interacting with our AKS cluster via the portal and via our own system is that when we are interacting using Cloud Shell, I don't have to authenticate again. Reason being, I am already authenticated to my Azure account.
Got it.
So using my account, I don't have to perform that additional authentication again. I can
Got it.
directly start using my cluster. However, when I am using my personal machine, this machine is currently not in contact with my Azure account, or using this machine, I cannot directly interact. I need to authenticate first. So when we are using Azure CLI, the first thing that we have to do is authenticate ourselves. How will Azure know who is trying to access the resources? And it's not just for AKS cluster. Any resource that we try to access using Azure CLI from our own machine or from any remote location, first thing that we have to do is authenticate using that Azure CLI. So we authenticate, and once the authentication is done, then the process is pretty much similar to what we were doing in Azure Cloud Shell. We specifically query our resources, we perform our operations, and we are good to go. So the additional process that we do in our remote machine is the authentication to Azure using Azure CLI, so that Azure also knows that one, known identity is utilizing the resources. All right.
Got it.
All right. Great. I don't know, my portal is taking a lot of time today. All right, till the time it creates, let's move on to the next segment now. So the next segment that we'll be discussing now is the actual component, which is integrating Azure Active Directory with Kubernetes cluster, with our AKS cluster. So we have discussed what Azure Active Directory is, how Azure Active Directory works in a brief. All right. We have also seen how AKS is managing the accesses as of now. The generalized access provide everybody to do anything in my cluster. Also, there is no identity management out of the box that is provided in AKS or Kubernetes. We use RBAC, we use service accounts or roles and cluster roles, which we just discussed, in order to limit the utilization of the resources. But when we are working in an enterprise, we have our cluster set, we have our enterprise cluster set. So we want a standard authentication mechanism for all our resources. So this is something which we can impose using Azure Active Directory. So with Azure Active Directory, we can enable that second authentication to our AKS cluster also. The first authentication being authenticating to Azure in order to use the resources. The second authentication being to again authenticate with Azure Active Directory in order to utilize the AKS cluster. So let me just show you how the mechanism works right now. So this is the standard mechanism. So in the standard mechanism, what we are doing, we are having a resource group, we are having a AKS cluster. All right. We have our user. The user simply triggers the command in order to connect to the AKS cluster. The cluster retrieves or provides all the configuration information to that particular user. That cluster config is stored in user's machine now. So this is the general flow which we just discussed. As soon as I am done with this, I have the cluster configuration in my machine and I can start using the resources in my AKS cluster, or I can start performing the deployments in my AKS cluster. Now, when we incorporate Azure Active Directory with AKS cluster, the authentication mechanism changes slightly. So this is what happens when we enable Azure Active Directory in our authentication mechanism for AKS. It's pretty small. I'm not very sure will it be visible to everybody or not. I'm just quickly see if I can pick up
I made it
the
full
actual.
screen, sir. Don't worry. Like I'll make it full
Okay.
screen.
All right. So in the AD enabled cluster, how the authentication mechanism flows is, first of all, the user will trigger AZAKS. It will be the fetching of the config or the credentials. That is the standard process a user will do. Now what will happen is the user will be getting a prompt to authenticate first. The user will be going through that authentication prompt, providing the authentication token which Azure Active Directory has returned. All right, then Azure Active Directory authenticates that particular user. All right, if the authentication is successful, then user is successfully authenticated to Active Directory and the user is provided the access to the cluster. Once the cluster access is provided, AKS will provide user with the queue configuration so that user can start performing its actions. And if the user is not authenticated to Active Directory, the user will be denied the access to our cluster. So this is how the authentication mechanism changes when we incorporate Active Directory in our AKS cluster. So it helps securing the access to our AKS cluster. Also, we can restrict the usage, the resource or object usage for every particular user in our cluster. Let's say there is one user in my organization who is the DevOps professional, and let's say I am a developer. So being a developer, I will not be requiring the access to alter the resources. I will not be requiring the access to modify any changes in my cluster. So what the DevOps professional can do with my Azure Active Directory user, he can create the cluster role, which we just saw, restrict me to just list or view the resources in my cluster and then provide that access to me. So even if I'm authenticated using these same credentials, I will only be having that restricted access. I will not be able to do anything out of that defined umbrella of my access. So this is how we control or set up a governance on our mechanisms or a AKS cluster. All right. It's taking forever.
Sir, will you take one question from Koti? Koti is asking a question on like,
Yeah, please.
is role-based access similar to? Arey, okay, fine. Is
Is role
role-based
based
access similar?
differentiate much regarding Active Directory. So when we talk about role-based access is what we just discussed. We'll be using service accounts. We'll be using role bindings. So when we are comparing it with Active Directory. So Active Directory is to integrate or enable identity management in our cluster. Behind the scenes, if I show you again, we are doing pretty much the same iterations. We will be creating a role or a cluster role. We'll be defining those privileges and the resources on which those privileges are given, and simply will be attaching those role to a particular identity. So what Active Directory is bringing for us on the table is the identity management, which we do not get out of the box from Kubernetes. So in this fashion, we can integrate Active Directory, or we can have our identities authenticated with Azure AKS cluster using Active Directory. So behind the scenes, the restriction of resources, the restriction on object utilization follows the same paradigm. We go via roles and cluster roles. What we are getting via Active Directory integration is the identity management. Using our Active Directory users, we can directly attach those roles to our Active Directory users. We don't have to explicitly create new service accounts for every user. We have our Active Directory users already. We simply attach our roles to those identities and we provide access to them. All right. So great. So Valenki Koti, I hope it answers your query. All right. So
Sir, sometimes probably even because of the browser also it will take more time. Like
oh,
if it's done on Edge or Chrome, it will take
hmm,
more time. Like even because of the browser, sometimes the deployments don't happen properly.
okay. So I'll just leave a note on the chat.
Yeah. Like working with this one is also fine. Like you can go with the Chrome only. Sometimes Brave browser
Mhm.
might not have good deployments happening because some browsers have their own issues sometimes. I don't know
Yeah,
why.
actually.
Logic App doesn't give this Logic App the studio as soon as we get in for creating the new logics out there. Like we have to go for the this one only. Like Edge sometimes Chrome also will stop
Yeah.
working. I don't know why. Yeah, sure. I think Alanki, I hope it answers your query. Yeah, I think yeah, it answered your question.
All
Perfect.
right. So let's move ahead then. So now we'll jump into our AD integration with AKS cluster. So
Sure.
we'll go through these steps, what we have to do in order to enable the Azure Active Directory authentication to our AKS cluster. I hope my portal works fine, else I'll be sharing all these steps with you guys. So the first thing that we have to do is we have to create a server and a client application. Those server and client applications will actually help us perform the actual authentication with Active Directory. And both those applications will be created in our Active Directory only. All right. So let's jump on. So how we start off is we navigate to our Active Directory. Now in the Active Directory, you'll see there are app registrations. Now this is where we create our server and client application. These server and client applications will be integrated with our AKS cluster, and these applications will help us authenticate to our Active Directory. All right, this is how the flow will proceed. So we go on to app registrations and we'll create a new registration. So here we'll be providing the name. First we'll be creating the server application, then we will create a client application. AKS server app. Yes, server app. So we'll just keep these details. Keep these details handy with me. As we are working with a single tenant environment, we are only having one tenant. So we'll be keeping it to single tenant. If you are having a multi-tenant environment or you are interacting with two different Azure accounts and you want this application to be cross-functional, then you will be creating or selecting the multi-tenant option. Right now, I'm only having a single tenant, so I'll keep it single tenant. Now we have the redirection URI. This redirection URI will simply keep as our app name only, will not change it. All right. And once it is done, we'll click on register. All right. So as you can see, our application is created. This is our server app, which we just created. So now there are some configuration changes that we have to do. First of all, what we have to do is navigate to manifest. And in the manifest we have to edit the group membership claims. Now what this group membership claims will do is, this group membership claims will help us to enable the authentication for users as well as groups. So we'll change this value from null to all. Oh my god, I have to use double quotes, I used single quotes. All right, and save it. All right, so our manifest is updated. The manifest step is done. Now we have to provide some permissions. So before giving the permissions, we'll create a secret. This secret will be used in our authentication as well. So we'll create a secret now, a client secret now. All right, here we'll be creating a new client secret. We'll keep the name same, AKS server app. So we will be keeping it to 3 months. Anyhow, I'll be deleting it post the demo. Now copy this value as well. All right, so our secret is done. Then the next step that we have to do is we'll go to the API permissions then. And here we'll be selecting add permissions. In add permissions, what we'll select is we'll select Microsoft Graph. And Microsoft Graph, first we'll go to the delegate permissions. And in the delegate permissions, we have to search for directory. So here is our directory. We'll expand it and we have to give it the directory read all permission. So first this is done, then we have to navigate to users. That is something which should be there by default. So here if you can see user read is already there. If it is not there, then just select users and enable the user read all permissions. All right. So once this is done, then we scroll up and go to the application permissions. Now in the application permissions also we'll select for search for directory and give it the read all permission. Directory read all permissions. And once this is done, click on add permissions. All right. See, the permissions are added. Now once the permissions are added, we need to provide a consent for the directory as well. Unless or until we provide the consent, these permissions will not be in action. So here you can see we can grant the admin consent. So we'll simply grant this consent. All right. Now the consent is granted and these permissions are active now. Now in the next step, what we have to do is we have to expose the API. This application that we have created, the server application will be exposing as the API so that our client application can utilize it in order to authenticate. All right. So we'll go on expose API and we'll create a scope, add a scope. All right. Now as you can see, this application ID is nothing but the application ID of our server app that we have created. So I'll copy it so that once I add the scope, I can show you guys that this ID is the same as our server application ID. All right. Now we'll save and continue. Now we have to specify our scope name. So we'll keep the scope name same as the server app. And click on add scope. So it will add the scope. All right. So as you can see, our scope is added. Now what we want is we want to get the application ID. So this is the application ID. In the overview screen, you can see the application or client ID. This is the application ID of the app that we have created. So if I show you, this app ID is the same as what we were getting in the app ID URL. All right. Now this concludes the server side configurations that we have to do. The server app that we have to configure. Now we have configured our server side application. Now what we will do is we will create the client application as well. So we'll scroll back and create a new registration. And for this was the server, this is the client. So here I'll create the, it is server, we'll name it to client. AKS client app. All right. We'll keep it the same single tenant. We are only having one tenant. In the redirection URI, we'll specify our app name only and register. All right, it is done. Now we'll directly move on to, in the client application, we'll move on to the API permissions directly. API permission, then we'll click on add permissions. Now in the add permissions, you'll see we have something called as my APIs also. So we'll navigate to my APIs. All right, so it, okay, there are some network issues. Let me refresh it. All right. See, now this AKS server app, it is the server application that we created. And why are we able to see it in my APIs? That is because we exposed the server app as an API in the previous step. That's why it is available as my APIs here. So we'll simply select it, and in the permissions, we'll select the AKS server app and add permissions. All right, the permissions are added. Now we have to grant our consent for this permission as well. We'll grant the consent here. All right, we have the consent. Now what we have to do is this final step will go to authentication. In the authentication, scroll down at the bottom and see allow public client flows. Enable the following mobile desktop flows. So we'll simply enable it. And then we'll save it. Alright. Now the client configurations are also done. So what we need now, we need the client application ID as well, and tenant ID. Tenant ID will remain the same. You can take it either from the server app or from the client app because we are working with the same tenant. So this will not change. All right. Now what we have done is we are done with our server and client app configurations. And now the final step that we do is to create the AKS cluster, which will be Azure Active Directory enabled, and then try to access our resources using this authentication mechanism that we have just incorporated. So let's see. So I'll open Cloud Shell. Alright, so what we'll do is we'll create a new resource group first and we'll use Azure CLI to do it because in the portal we don't get all these options. So we'll be utilizing Azure CLI. Earlier, AD integration was only possible with the newly created clusters. So while we are creating the cluster, we have to integrate Active Directory with it. But now we can integrate Active Directory with an existing cluster as well. So that feature has also been incorporated by Microsoft. So AZ group create, and then we'll specify the name of our resource group. That will be ADAKS demo, and then location, we'll keep it as East US. All right, so our resource group is created. Now what we have to do is we have to create our AKS cluster. So I'll just write the command here first and then I'll paste it. Easy AKS create. AKS demo clusters. Then we have resource group. The resource group is ADAKS demo. ADAKS demo. Then we have generate SSH keys. Now comes the Active Directory integration part, AAD server app. So here we'll specify the app ID of our server application that we had created. Then server app secret. Where is the secret? Here is the secret. So this is the secret that we had created for our server app. Then we'll be specifying the client app, AD client app ID. Client app ID. Here is the client app ID. And finally our tenant ID. AD tenant ID, the tenant ID that we copied. Alright, so I believe I have all the parameters set. Now I'll just copy it and apply it and open. Like my portal is pretty slow, so I'm not very sure. It might take more than expected time. Alright, it has started creating the cluster. So let's hope the cluster is created soon. So once the execution is done, we will be having a AKS cluster created with Active Directory integrated into that cluster. So this is what we are trying to achieve here. It's taking quite some time now. So once the cluster is created, what we will be doing is we have our cluster role and cluster role binding manifests already created. So what we do as the next step is we deploy the cluster role binding, and in the cluster role binding you can see we have the subjects specify the target with which we have to associate the corresponding cluster role. So in the subject, we will be having the kind user, because now we are integrating with Azure Active Directory. So we will directly attach the roles to our Active Directory users. We don't have to create additional service accounts. We directly attach the role to a specific user, and then that user will only be having those privileges. And if we have to modify the permissions, the only thing that we have to do is, excuse me, update the role here. So here what we have to do is we have to select the kind as user, and in the name what we have to do is we have to specify the fully qualified username. So how we can get the fully qualified username, let me show you that as well. So in Active Directory you navigate to users. So we navigate to users, and in users let me open my user up. So any user that you select in the profile section, in the identity you'll see the user principal name. User principal name is what you have to use in this name field. All right, you will not be using the standard name of that particular user. You will be using the user principal name. So user principal name is something that we have to specify in our cluster role binding here. And once we deploy our role and cluster role binding, then this particular user will be having these privileges over these resources. So I will be having the permissions to view the nodes in our cluster. All right, okay, so this cluster is created. That is good. So as you can see, our cluster is created. Let's see. in AKS. So here you can see we have the AD AKS demo cluster. So now I'll simply get the connection details. Now you have to get the credentials. So now what I'll do is, so okay, I'll not be having this right. So AZAKS get credentials, then my resource group name, and then name of my cluster. So what we will be doing is I'll be specifying the user here also. The user that I'll be specifying here will be admin. So the cluster admin is the user which I am using right now. So I'll simply click enter. It'll override my context. Override. All right. So now the kubeconfig file from our new AKS cluster has been added to my user context. If you can see in this path, let me quickly show you as well. So if I do a cat, so this is the different context or kubeconfig files that we are having. So we have one for cluster admin AKS demo, AD AKS demo cluster. This is the latest context that we are having. All right. So this is the place where all the kubeconfig files are stored for our Kubernetes clusters. All right. Check this show cluster. Is it config get context? So let me show you something. DPA resources, it is instance. Alright, it is not showing you right now. So what you can do is you can also see your context and your clusters. So how you can see your kubeconfig is in the home directory. The user home directory that you have there, you can see all your contexts and your clusters that you are having, the file that we just saw here. So
Sir,
now let us
can
try.
you like a little bit zoom for the bash which we are having right now?
Okay,
Because
let
a little bit.
me just see if I can text size. I'll keep it large and
Yeah.
okay. Okay, is it better now?
Yeah, yeah, it's better. It's better.
So what I can do is I can, okay,
Ah, perfect, sir. Perfect.
clear now.
Yeah, yeah. Sure, sir.
All right. So now what we will try to do is kubectl get nodes. You must. So NO is the short form for our nodes. So now as you can see, I am having a cluster with 3 different nodes. I'm having 3 nodes here and I can very well open it up. Okay, so now what we will do is, now we will deploy our files. So first of all, what we have to do is, first of all, we'll be deploying our cluster role, and then we will be deploying our cluster role binding. So I'll create a new file here. All right, so this is my cluster role. Okay, let me show you. So as you can see, the cluster role is created now. So okay, so let's first apply our cluster role. So to apply kubectl, apply -f to specify the file cluster role dot YAML. So now as you can see, the cluster role has been created. Now we will apply the cluster role binding. Okay. Okay, so this is our cluster role binding. This is the cluster role name. It is the same that we have specified in our cluster role. And as our subject, this particular user is the user which we are utilizing in order to attach this role to. So we'll do save it and apply cluster role binding. All right, so now my cluster role and cluster role binding has been created. Guys, please excuse me for a moment. I'll be right back.
So hey folks, like don't worry, please do drop your questions down in the comment section here so that we can address it afterwards also, and also make sure that you are in mind with all the things that we are just doing. So don't worry, even if you just miss out, stay here, just work on it over a course of time. It will be in your hand. So yeah, he'll be joining soon, so don't worry about that. So any questions we can put it in the chat section so we can address it later. And perfect. All right, you guys can keep your examples of kubectl and commands and things like that that really didn't work. We can figure out that as well in the session. So yeah, everything is in your hand. So don't worry, it's all still the kubectl apply -f commands with a lot of YAMLs which are always there. So yes. And also make sure that you just follow us on the Telegram. The Telegram channel is here, and this is our website. So do check it out and do join our community, and everything will be notified through that. And so on, folks. Sure. Then. All right.
Thanks for
Sure.
waiting. Yes, let me start sharing my screen again. I have to. Okay, there was some issues in my charging cord. Okay, so where were we? So we had deployed our
Bindings.
bindings and our cluster rules. So now what we will try to do is, currently we are logged in as the admin. So what we will do now is we will try to log in as a standard user. All right. Now when I am specifying this command again, what is happening is now I will not be the admin of the cluster. Now I will be my user, Naveen. All right. So this is the difference that it makes. If we specify the hyphen admin flag, using the admin flag, we'll be using the cluster as the cluster admin. But if you do not specify the admin flag, then you will be using the cluster as your own user. This is my user. So now what I will be doing is, now you see the difference? As the cluster admin, when we specified or triggered the command kubectl get nodes, we were directly shown the list of the nodes that are available in my cluster. But now when I am trying to execute any command here, the first thing it is asking me is to authenticate myself. And now we have enabled that additional authentication layer. So what we have to do now is, using this link, we have to authenticate, and this is the token that we have to utilize for that. So I'll specify this token. I'll select the user which I am using to authenticate. Skip it for now. Alright. We are trying the client app. See the client app that we utilized. This client app is communicating with the server app that we created and authenticating us. Now see, as soon as I am authenticated, I am able to see the nodes now. All the nodes that were there. Now see the difference? When I was trying to get the nodes, I was authenticated and I was shown the list of all the nodes that are available. But now when I'm trying to get the pods that are deployed in my cluster, I am not able to list those pods because I do not have the permissions to operate anything on the pods. And this is something which we can cross verify from our roles file. It was cluster rule, right? That we created. So see, in the cluster role, the only resource that I have specified is nodes. So apart from nodes, if my user now tries to access any other object in Kubernetes, I will be getting the forbidden error. I am not allowed to list any of the other resources. All right. So this is how we enable Active Directory in our cluster, and this is how we can restrict different users to different set of permissions and privileges. So now I have made my cluster access more secure. So now I can very well attach different roles, different set of users based on their requirements, so that the users are only having the permissions to what they are designated to be. We are following the least access principle here. So we should always specify or provide the access to any user or any identity to what that particular user or identity is designated to. All right. So now we have incorporated Active Directory as well as the least privilege principle. All right, guys. And one more thing that I was showing you earlier is the Kube API resources. Now, what this does is when you specify the Kube API resources, if you remember, whenever we are creating any resource, we created cluster role, we created cluster role binding. So there is an API version that we specify. So this is the API version, or this is the API resource that falls under a particular API. So there are two type of API resources. One is the namespace API resources, the resources which falls under the scope of a namespace. So if I have restricted the permissions to a namespace, all the resources that follow the namespace paradigm will be applicable. But there are some resources which are not namespaced, that are cluster level resources. For example, nodes are cluster level resources. I cannot restrict the access to a node based on the namespace because they do not fall under any namespace. All right. And if you want to see which all resources are namespace scoped and which all resources are cluster scoped, this is how you can do it. kubectl API resources and then the namespace flag to true. Now the namespace flag true will return all the API resources which fall under the namespace paradigm. All right. Here, as you can see, our deployments, the most common resources deployment is there. We have services, we have secrets. So all these pods, all these resources are namespace based. So they are dependent on a namespace. And if you want to see all the cluster level resources, the resources that are cluster scoped or cluster wide, you simply set this namespace flag to false. See, now here you'll see all the resources which are not namespace scoped, and you can see we have nodes in here as well. Namespace, we have the API services, we have our cluster roles and cluster role bindings as we discussed, because cluster role and cluster role bindings are for cluster scoped accesses. All right. So thanks guys. This concludes our demo and our workshop for AD enabled AKS clusters and how we can integrate Active Directory with our AKS clusters and what benefits we are getting by integrating Azure Active Directory with our AKS clusters. So if there are any questions, please do drop them in the chat box, and you can also reach out to us. As Vishwas mentioned, we are having a Telegram community channel also where you guys can reach out to us and post your queries and questions. So we'll be more than happy to take them up.
Sure. I think thank you so much, guys. I think perfect. The session got ended, and I think the deployment didn't happen through the portal, but we just tried doing
Yeah,
it sort of.
the portal deployment which I was doing was in order to show the initial cluster roles and all to the audience.
Mm-hmm.
But the portal is taking a really long time. It's still in creation.
Yeah,
But the good thing
sometimes
is,
browser makes huge difference sometimes.
exactly. So the good thing is we got it running via the Azure CLI. So the
Yeah.
main
Sir,
components and
and I
all the
wanted to
components.
ask you one question.
Yes, please.
Like,
Mhm.
if we attach too many namespaces, is it more secure when we think of the Kubernetes perspective? Because YAML is only a kind of an vulnerability that we'll be adding for our system, because
See,
YAML is really vulnerable. So,
so when
namespaces, will it really affect the security that we are thinking for us?
exactly. So namespace, when we talk about namespace is nothing more than a logical binding for my resources. All right. When we talk about Azure, Azure has the concept of resource groups, right? We can have multiple resources in different resource group. We can have multiple resources in the same resource group. What is a resource group? Resource group is nothing but a logical identity which binds those resources together. All right, I am creating a logical segregation between my resources. Maybe I have a resource group for staging, maybe I have a resource group for production, I have different resource groups for different projects altogether. All right, so resource group is providing me a better manageability of my resources. Also, I can restrict the access to a specified resource group for different users also. So I'm getting better manageability and I can granularize my access control. In the
Hmm.
same fashion, namespaces works in Kubernetes. I can have different namespaces for different environments or for different projects. and I can granularize my access or my RBAC rules based on those namespaces. As we discussed, we have roles and cluster rules.
Mm.
So when we talk about granularizing the access, when we are talking about providing access to just a specific namespace, then we'll only focus on the roles so that we can restrict the access to only a specified namespace. Let's say I have project, and in the project I'll be having different teams. I'll be having a dev team, I'll be having a QA team. So the dev team will own the dev environment and QA team will own the QA environment. So what I can do in this scenario is I can have two namespaces, dev and QA. In the dev namespace and the QA namespace, I'll be having the same services, the same components deployed. The only difference will be in the dev namespace, I can give access to all the dev folks. And in the QA namespace, I can keep all the QA folks. So, first thing, their work is not mugged up. Second, they do not interject in each other's environment. They have their own environment. They can access there, they can test, validate, do anything and everything that they want. So this is how namespaces makes our lives easier in Kubernetes.
Yeah, that's true. That's true. Because yeah, when
Yeah,
you go to hacker one, right? If you just type Kubernetes YAML, it's the number one list of all the vulnerabilities that comes up. And yeah, that's what I was
absolutely.
thinking of.
So that's the
Yeah.
main scenario. If you are deploying your manifests in the plain default namespace, so that is something anybody can access, because as soon as you are getting into a cluster, unless or until you are not restricted via service accounts or this AD integration, you will be having access to the default namespace. So anything and everything that is there in default namespace, you can alter it.
That's true. That's true. Yeah, perfect, sir. I think it's time for us to end the broadcast. And thank you so much, folks.
Okay. Thanks, guys. Thank you so much for joining in. We hope that you guys got to learn something new and interesting. So we'll see
Yeah.
you again in the next meetup. Till then,
Yeah.
happy learning and goodbye.
Bye.